Hello, my name is Shanahan, and in this video I'm going to be discussing circuits. Every circuit has a power source, like a battery, that gives off a constant voltage. Voltage is the amount of potential energy between 2 points on a circuit, which is measured in volts. Circuits contain resistors, which are measured in ohms. They use up voltage in the circuit. One example of a resistor is a light bulb. In circuits, there is a flow of energy called a current. This flow is the movement of electrons going throughout the connecting wire. When moving past a resistor, the electrons slow down. This means that resistors have resistance. The number of resistors dictates the velocity of the current. For all of these things to be true about circuits, the circuit must be closed. Now I would like to talk about the difference between parallel and series circuits. Series circuits have only one path for the current to travel. In this type of circuit, the current is constant. A parallel circuit has multiple paths for the current to travel. Every loop gets access to the total voltage. Next, I would like to look at a scenario in which I used electric snap circuits, which is a kit that lets you build your own circuits. I also borrowed an ammeter to find voltage and current for this example. As you can see in this first picture, I set up a parallel circuit. There are two switches and a resistor in each path for the current to travel through. For this situation, we are going to be finding the total current in the circuit. Now, before beginning this type of problem, first you must think about the variables that you need to find. Using Ohm's Law, you know that you must find the total resistance and the current to find the voltage. To find the total resistance, we must find first the amount of ohms in each individual resistor. To do this, we first measured the exact voltage of each battery, and then we also found the current that flows through the resistors with this particular voltage. We measured the current so that we could calculate the resistance in each of the lights.
Okay, so as we know that our end goal is to find the total current throughout the circuit. And to do so, we're going to use Ohm's Law right here. And one of the variables that we need is the total resistance. So we're going to find the individual resistance of each resistor so that we can find the total resistance. So as I explained earlier in the video, I used an ammeter to measure the total voltage coming from the battery from the picture that I showed before. And then I also used the ammeter to measure the currents going through each of these resistors. And as you can see, the switches are open in certain areas, and that's just so there wasn't any interference from the other one, so that I could find the current for that specific resistor. Okay, so let's get started. So first we're going to manipulate Ohm's Law to find the resistance for this individual resistor. So resistance equals voltage over current. And as I said before, we've already found the total voltage. And then with the ammeter, I found that the current was 22 milliamps. And then after converting that, it was 0.022 amps. So we're going to just plug that right into here. And this should come out to be 140 ohms. Then we're going to do the same thing down here. And right here, and for the current, I measured 32 milliamps, which converted to 0.32 amps. So we'll plug both of those numbers back in. And that should end up giving you 97 ohms. Okay, so now that you have both of your individual resistances, we're going to find the total resistance. And so to do this, for a parallel circuit specifically, we're going to use this equation. So 1 over resistance 1 plus 1 over resistance 2. Now, this equation can keep continuing depending on how many resistors are in your circuit. But for this, for the one we're doing, there's only 2, so we're only doing 2. And this the equation to find the total resistance for a parallel circuit is different from a series circuit. For a series circuit, it would just be R total equals resistance 1 plus resistance 2 plus ... depending on how many resistors are there. But we're using this since we're doing parallel. Okay, so then this is just going to be 1 over 140, 140 ohms plus 1 over 97 ohms. And then after finding this number, you do the reciprocal. So the total resistance should come out to be 56 ohms. Okay, so now that we have the total resistance and the total voltage, then we can finally plug it into the original Ohm's law. So the voltage equals current times the total resistance. So we're going to divide R. So then we're going to end up getting the current equals the voltage over the total resistance. So that would be 3.09 volts divided by 56 ohms. And then we would get 0.055 amps. And that's our total current. So we just solved this equation. So, yay.
There are possible sources of error when attempting problems like these. The batteries in the ammeter could be losing charge and becoming weaker during the experiment, and therefore not being as accurate in measuring the voltage and current. The resistance in the lights may not be exactly constant while the current is flowing, and we don't know the current in the circuit connectors. The batteries may also lose voltage during testing. Alright, thank you for watching this video. I hope you learned a lot about basic information and vocabulary that go along with circuits, and I hope this video really charged you up. Thank you.